In this video, we will talk about end behavior. When I see the equation of some polynomial, in my mind, I'm picturing a graph. Let me show you how. It's really all about the degree and the leading coefficient. When I talk about the degree, I'm talking about the exponent, the highest power. For example, if I see x squared, then I know that that's going to be a parabola, something like this. Unless there's a negative leading coefficient, in which case it's going to be an upside down parabola. Okay, now it doesn't matter if there are other things going around it. For example, if this was, let's say, 5x squared, all right, it's still going to have the same basic shape. It doesn't matter if it's 5x squared plus 3x minus 1. All that matters is the x squared being the highest power. Okay, and the same thing with this. If this was negative 5x squared plus 3x minus 1, it would still look like this. Similarly, if we up the degree to x to the third power, all right, the basic graph for a cubic is this type of thing. All right, sort of a positive capital letter N. And if it has a negative leading coefficient, then that just has the effect of turning that n upside down. All right, it's this type of end behavior anyway. And again, it doesn't really matter what else is going on. This could be 4x to the third power plus 2x squared minus 7x plus 1. But the basic shape, particularly the end behavior, is determined by the degree, the highest exponent. And I could keep going from there. If I have x to the fourth power, I have memorized that that's going to be like a W shape. Now, it won't always exactly look like a W, but the end behavior, you know, the way the ends will work, will always work like this. All right, and unless it has a negative leading coefficient. All right, in which case I know it's going to be an upside down situation. Okay, so this is what I know. Now, rather than going one by one, let's talk about all of the even degrees, like 4s and 2s, and let's talk about all of the odd degrees, like 3s and 5s. Start with evens. Notice the similarity between x squared and x to the fourth power. Alright, especially look at the end behavior. See how both of these branches are reaching up toward the sky? And when we had x squared, same thing. Turns out any even degree, whether it's going to be x squared or x to the fourth power, or x to the 10th power, or x to the 20th power, the end behavior is going to work the same way. Just like x squared went like this, and x to the fourth power went like this, they are all going to have this end behavior where they're reaching toward the sky on the ends. If they're positive, the degree will just tell you how many little waves there will be. But if all you care about is the end behavior, if they're even, you know the arms will be facing the same way. And if these were negative, like if I had negative x to the fourth power, or negative x to the 20th power, negative leading coefficient, then both of my arms are going to be facing down, like this. All right. On the other hand, just delete all this mess. Let's talk about the odds. Okay, let's use our cubic as a model. Remember our capital letter N? So this is going to be the end behavior for all odd functions. If it's positive, doesn't matter if it's x to the third power, x to the fifth power, x to the 21st power. The end behavior is going to work like this. All that's going to change is how many waves will happen in between. Alright, so maybe it'll go like this, and then it'll have several waves in between. Okay, depending on how high the power is. But the end behavior is always going to work like the capital letter N did. Alright, and sometimes I like to draw a big ol' N on there to remind me that the end behavior is still working the same. If these were negative leading coefficients, then remember it would have end behavior like an upside down N, even though in reality, depending on the power, there could be a crazy number of loops in the middle. So when they give me a polynomial like this, what I'm looking at is the degree, alright, in this case 7. And I'm looking at the leading coefficient and seeing that minus sign. The 10x really doesn't have anything to do with the end behavior. So as soon as I see that it's odd, I know it's going to be either a right side up N shape in terms of end behavior, or it'll be an upside down N shape. Okay? Because it's negative leading coefficient, I know it's going to have the end behavior of an upside down N shape. Now this is not cubic, so it won't just be an N shape. In reality, it has extra waves in between. Alright, but that doesn't really matter because all we need is the end behavior. So the bottom line is, on the left it's rising, and on the right it is falling. So as x approaches negative infinity, that's the left, the function is rising, so I'm going to say positive infinity. As we go to the right, the function is falling, so that's going to be negative infinity. Alright, so that's how end behavior works.